morning everybody. Today we discuss 1-carbon metabolism. 1-carbon metabolism. The main role is of the tetrahydrofolic acid. Tetrahydrofolic, which is derived from folic acid. The chemical name of folic acid is steroyl glutamic acid. The 1-carbon metabolism where tetrahydrofolic acid plays an important role. It becomes a bit confusing, but if we remember the sequence, it would be easier to remember and write it in the exam sheet. So serine will form N5N10 methylene. So it is methylene tetrahydrofolate. This can lead to the formation of serine again, or DTMP, that is thymidylate. This N5N10 methynyl can move both ways and it can form N5 methyl tetrahydrofolate, or it can form N5N10 methynyl tetrahydrofolate. N5N10 methynyl tetrahydrofolate forms purines, the C8 carbon, and this N5N10 methynyl tetrahydrofolate can again form N10 formyl tetrahydrofolate, which can again form purines, or it can form formyl methionine. So this is in a very nutshell of the 1-carbon metabolism where this reaction is taking place. Serine forms N5N10 methylene tetrahydrofolate. This is the most important step to remember. Then you go 2 arrows upwards, 1 arrow downwards. 1 arrow downwards you form N5 methyl tetrahydrofolate. The upwards arrow you form N5N10 methynyl tetrahydrofolate, which forms N10 formyl tetrahydrofolate. Okay. Now these are the products, these sides are the products which are formed from this tetrahydrofolate compounds. N5N10 methylene tetrahydrofolate forms serine and thymidylate. N5N10 methynyl tetrahydrofolate forms C8 of the purine, and N10 formyl tetrahydrofolate forms purine and formyl methionine. Okay. Now we have seen serine forms N5N10 methylene tetrahydrofolate in the presence of enzyme serine hydroxy methyl transferase, which requires a PLP, and it will require tetrahydrofolic acid. There will be removal of glycine. So this reaction forms N5N10 methylene tetrahydrofolate. N5 methyl tetrahydrofolate can also be derived from choline and betaine with the addition of tetrahydrofolic acid. This N5 methyl tetrahydrofolate takes part in vitamin B12 reactions because it will help the methionine to form SAM and then finally homocysteine. The CH3 will be taken by any compound which requires methyl group. So it's a transmethylation reaction. N5N10 methynyl tetrahydrofolate can be formed by histidine amino acid. This histidine amino acid form iminoglutamic acid FIGLU, which takes up tetrahydrofolic acid and forms N5N10 methylene tetrahydrofolate. Okay, and N10 formyl tetrahydrofolate can also be produced from formate, which can be through the amino acid glycine or tryptophan. So if we say tryptophan and glycine can form formate. This formate can form N5N10 formyl tetrahydrofolate, which can form purines, which can form formyl methionine. Histidine can form FIGLU. When it reacts with tetrahydrofolate, it will form N5N10 methyl tetrahydrofolate, which will form purine and C8. Serine forms N5N10 methylene tetrahydrofolate, can form serine and DTMP. N5-methyl tetrahydrofolate takes part in the reactions of methionine with vitamin B12. It is formed from choline and betaine. Now coming to this reaction where FIGLU has been formed, if there is absence of tetrahydrofolic, if there is deficiency of folic acid, this reaction does not take place, and thus FIGLU is excreted in urine. So this can be seen for deficiency of folic acid. So that's all for carbon metabolism. A difficult metabolism to remember because there is lots of methynyl, methylene, methanol, formyl taking part in the reaction. But if you remember which is the first compound that is to be formed in this cycle, then you remember N5N10 methylene tetrahydrofolate. One reaction downwards, two reaction upwards. N5N10 methynyl tetrahydrofolate will be formed. N10 formyl tetrahydrofolate and N5 methyl tetrahydrofolate will be formed. Methylene tetrahydrofolate is derived from serine. It can form serine and DTMP. N5N10 methynyl will be forming purine C8. N10 formyl tetrahydrofolate will form purine C2 and formyl methionine. This will take part in vitamin B12 and methionine reactions. Glycine, tryptophan formate producing the first one. Histidine producing N5N10 methynyl tetrahydrofolate. Serine producing N5N10 methylene tetrahydrofolate, and choline and betaine producing N5 methyl tetrahydrofolate. Thank you.